All right, so this is the second video after the introduction, where now our problems get to look a little more complicated, but again, we're using the same idea. Are my denominators identical? In this case, these quadratics are identical. Same signs, the same term values. It looks good. So then I don't need to worry about doing any manipulation. I'm just going to rewrite and add the numerators. 2x plus 7, parentheses, divided by 2x squared plus x minus 21. Now, at this point, you would probably just write down x cannot equal, yada, yada, yada. But before we do that, we're going to have to factor this and make sure that we still can't simplify it further, okay? So we have to, in this case, use the area model. So I'm going to erase this, and I'm going to factor this out. So I'm going to make my little, as you can see my guy rolling around. Diamond problem, 2 times negative 21, that's negative 42. This sounds familiar. Plus 1. This is a plus 1. That's the coefficient of a middle term. 6 times 7 comes to mind, because I think we did this problem earlier, before. And since the middle term is positive, the biggest value of the two has to be positive, plus and minus. Make a big area model. 2x squared minus 21, 6x, oops, and 7x. Let me push this up so you can see what I'm doing. So, just by looking at this, I'm going to break this down. This would have to be 2x, and this would be x. X times 2x, 2x squared. 7x divided by x is positive 7. Oh, notice this. Notice that. Okay? It's a good thing we're checking. Always check before you write your final answer. Hey, I have this quadratic. I'm going to put it in factors to see if I can simplify it further. Negative 6x divided by 2x is negative 3. Yes, because negative 3 times 2 is negative 6, yes. And to verify negative 3 times positive 7 does equal negative 21, it does. And now what's happened is my factors are 2x plus 7 times x minus 3. And notice that these two are identical, numerator and denominator, identical binomials. Therefore, when I divide them, they're equal to 1, right? So this becomes 1. And my final answer is now 1. The numerator is still 1. It doesn't become 0. It's 1. X minus 3, where x cannot equal, say 2x plus 7 equals 0. That would be negative 7 halves and 3. This is my final answer. Okay, Mr. Cerna. So how did I get 1 here? Let's take this and break it apart. Technically what I have is, and I'll do it in a different color, just for those of you that still have a question, this is technically 1 times, well, this is still multiplying by 1. So I have 1 over x minus 3. And so this turns into this, which leads me to that. Let me roll this up again, because this is multiplied by 1 still. This converts into 1. 1 times 1 divided by x minus 3, put this in parentheses, leads me to this final answer. Remember, when we're multiplying and dividing, it's easier to manipulate than it is when you add and subtract, okay? This is still 1. 1 times 1 divided by x minus 3. Or in other words, what I did was I took this apart and did this. 2x minus 7 divided by 2x minus 7. And now you see where I get my solution. Okay? I got a couple more to do. I'll be a little faster. Same thing. Identical. Yes, they are identical. So what am I going to do? I'm just going to add my numerators. So I'm left with 5x plus negative 15 over x squared minus 2x minus 3. Since it's identical, and based on the previous problem, I'm probably going to rewrite this as factors. And I believe the factors are x minus 3 and x plus 1. Because when I multiply negative 3 with 1, I get negative 3. When I add negative 3 plus 1, I get negative 2. The reason I was able to skip the area model here is because my leading coefficient is 1. Okay. So what does this yield? Well, I noticed that, in fact, I will just do the work on here. I noticed that plus minus, I'm going to rewrite it. And some of you probably already rewrote it or saw it. So I'm going to do that. Okay, so what happens when I have this now? Well, don't forget parentheses. I have a group of 5x minus 15. I believe I can factor out 5. This term and this term have a common multiple of 5, or common factor of 5, whichever way you want to look at it. So I'm going to divide out by 5 and only 5. I can't do x because this is a constant. So I have 5 times x minus 3. And if I would distribute 5 times x and negative 5 times 3, I get my original expression in the numerator. And at the bottom, look what I have. X minus 3, x plus 1. You can barely see that. Giant ones right there. My final answer is 5 divided by x plus 1, where x cannot equal 3 and negative 1. Okay. All right. And in the next video, we'll do a couple of little more complicated ones. The only reason they're complicated is because it requires more steps than what we've done here. That's it.